Now that we have looked at simple probability, there's one other form of probability that you should be aware of. That's called geometric probability. So what exactly is geometric probability? As the term suggests, it is the probability in which we deal with areas of regions instead of the number of outcomes. So the formula looks something like this. We have got favorable region over the area of the total region. This is basically favorable outcome over total outcome. It remains the same. The only differentiating factor is that instead of numbers, we have got areas. Let's have a look at an example. A typical problem might be this. If you're throwing a dot at the rectangular target below and are equally likely to hit any point on the target, what is the probability that you will hit the small square? So the formula is basically favorable region, which is this. So favorable region will be 5 into 5, which is our smaller square, over the area of this total rectangle. That is 25 into 10 because it's a rectangle. So we are looking at this 25 over 250, which is 1 over 10. Look at this, 1 over 10. So this means that there is a 1 in 10 chance that a dot thrown at the rectangle will hit the small square. Now let's have a look at a couple of questions. In the figure above, the radius of the circle P is 2. The radius of circle P is basically this, 2. The radius of circle Q is 4. The radius of circle Q is 4. And AB is the diameter of the largest circle. AB is not written here, so I'm assuming this is A and this is B. If a dot is thrown at the circular target and is equally likely to hit any point on the target, what is the probability that the dot will hit the shaded region? So how can we calculate the shaded region? We calculate the areas of these two smaller circles and then subtract these from the bigger circle, and we will have the area of the shaded region. Let's begin with this smaller circle. Let's say, what's the area of circle P? That is pi r square, which is r is already given to us. Pi into 2 squared, we have 4 pi. Let's keep it in terms of pi because it's easier to calculate. Then we have circle Q. So what's the area of circle Q? That is pi r square again. What's r in this scenario? We've got 4, that's already given to us. So pi into 4 squared, we have 16 pi. Now we need to calculate the area of the bigger circle, and the diameter is already given to us, that is AB. So the area of, let's say, bigger circle, I'm just calling it B, bigger circle. Okay, so what's the radius of this bigger circle? If this is 4, this is also 4, this is 2, this is also 2. So the total diameter is 4 plus 4, 8, 8 plus 4 is 12. So the radius is basically 6. You divide this by 2, you get the radius. So we have pi r squared, pi into 6 squared, which is 36 pi. 36 pi is the area of the bigger circle. So how can we calculate the shaded region? That is basically the area of the bigger circle minus, we have, add these two smaller circles, we will get the area of the shaded region. B minus P plus Q. Basically, I'm talking about their areas. Please remember that. So let's do the math here. What do we get? B is 36 pi minus, we have got 16 pi plus 4 pi. That gives us 36 minus 20 will be 16 pi. So that's the area of this shaded region, but we are not done yet. What's the target answer? What is the probability that the dot will hit the shaded region? So probability is our favorable region over total region. So that leaves us with 16 pi over total, that is the area of this bigger circle, that is 36 pi. 16 pi over 36 pi, pi cancels out, see, and we can divide this by 4. 4 over 9 is our answer. That is option choice C. Let's evaluate this question. ABCD is a square. M is the midpoint of BC, okay, and N is the midpoint of CD. A point is selected at random in the square. Calculate the probability that it lies in the triangle MCN. So basically this is our shaded region. Now we are not given any numbers, so let's just plug in values. Let's say the side of the square is 2. So all the sides should be 2. This is also 2, this is also 2, this is also 2. Now M is the midpoint of BC. That means BM should be 1 and CM should also be 1. Similarly, N is the midpoint of DC. That means CN should be 1 and DN should be 1. Now we have got all our sides. Let's calculate the area of the square first. So area of the square is basically length into length, 2 into 2, which is 4. Now let's calculate the area of the triangle. Area of our triangle is half into base into height. Let's say NC is the base, that is 1, and height MC is also 1. So we've got half into 1, which is 1 by 2. Now we've got all the values. Let's just plug it into this formula, which is favorable region over total region, over total region. So our favorable region is the triangle, that is 1 by 4, divided by total region, that is 4. You can write it like this: 1 by 4 divided by 4. Let's convert this sign into multiplication. 1 by 4 into, we will have 1 over 4, which is 1 by 8. That's our final answer. Next question, and I'm sorry about this messy picture because I've drawn it myself. Okay, a circle is inscribed inside a square. Point Q in the square is chosen at random. What is the probability that Q lies in the shaded region? So let's evaluate the figure first. We have a square, we have a circle. How can we calculate the area of the shaded region? So you subtract the area of the circle from the area of the square, we will get the area of the shaded region. Let's do the math. So the area of the square is basically, area of the square is 6 into 6. The side is already given to us. 6 into 6, which is 36 cm square, or whatever the units are. The next thing is to calculate the area of the circle. How can we calculate that? That's important. So if this side is 6, that means the diameter is also 6. You see, every side is equal. If this is 6, this is 6, this is 6, this is 6. So if this is 6, this has to be 6 as well. So if the diameter is 6, the radius is 3. So the area of the triangle is if the area of the circle, I'm just drawing a circle here. So that will be pi r square, that is pi into 3 squared, because the diameter is 6, so radius has to be 3. We have 9 pi. That means area of the shaded region is, 36, area of the square minus area of the circle. 36 minus 9 pi. This is the area of the shaded region, but we are not done yet. We have to find the probability that Q lies in the shaded region, and that is, probability is favorable region over total region, over total. So our favorable region is this, 36 minus 9 pi divided by total, which is this, the area of the square, divided by 36. This comes out to be 0.215, or you can say 21.5%. This is our answer.